I believe we're online and on the air. Hello, everybody. Hi, folks. I'm super happy that you join us today for this important session on pen testing for IoT and embedded systems. Uh, I'm Shemek. I'm with SAA for 16 years already, and I be our host today. On behalf of entire SAA team and in particular for Competency Center Embedded, thank you for joining us here, for taking your time. Uh, we know that your time is super precious, and we're prepared a session that we hope you will be enjoy, will be insightful, practical, and worth your while here. Uh, Before we start, just a few technical notes. The webinar will be around 60 minutes, including short Q&A at the end. Feel free to drop your questions here in the chat. We will review them and answer at the end. Yes, session gonna be recorded, and then we will be sharing recorded and materials afterward, most probably on Monday. Okay, so yeah, move forward with this, and we are ready to kick this meeting off. Today's topic: how do we ensure our connected products, IoT devices, are truly secure? With cyber threats evolving rapidly and embedded system becoming more critical in everything from customer electronics to industrial devices, security can no longer be an all thought. That's why penetration testing comes in. And now, just as a one-off exercise, but as a key part of your product development risk management strategy. We're gonna cover pen testing and tell you why it's essential for IoT products. Really important because of new Cybersecurity Resilience Act, US Cyber Trust Mark, the biggest business and technical challenges and how to address them, how to help you to tackle them. The first step, how to start testing your embedded devices, how to integrate pen testing into your development life cycle, and how to make it part of your broader product security strategy. Whether you're responsible for product strategy, work as a hand-on expert with hardware and firmware, this session is for you. So, Marek, the floor is yours.
Okay, so hello everyone. Thank you, Przemek, for your introduction. So, as you know, the topic of penetration testing is very broad and covers many areas. And during 1 hour long webinar, we will not have time to cover all the topics, but I will try to correct you and show you the most important things and how you should approach this topic to effectively implement into your project. So before we go into the details, a few words about me. So my name is Marek Natunewicz. Currently, I work as a solution architect in Embedded Competency Center at SAI. I have over 15 years of experience in designing and programming embedded systems. From the beginning, my professional path has been linked to embedded systems and working close to the hardware and low-level programming. For several years, I specialized in designing and implementing features, countermeasures, security controls, important from the security perspective, directly in embedded system at low-level area. When I'm not working, I spend time with my family. I have 2 wonderful daughters, and I also like running and reading books. Okay, so that's all shortly about me. So let's switch to our agenda for today. So today we will cover the key topic of embedded system security through penetration testing. So during the webinar, we'll deal with the points presented below and At the beginning, we'll try to answer for some basic question and try to define penetration tests in embedded systems with possible approaches. Then I will show you why penetration tests are so critical for embedded systems today. And next, we'll think about the common problem and challenges you might face. And at the end, I will show suggested approach, how to start, and which point to start implement as a first step. Okay, so let's start by thinking about the concept and some of the fundamental questions. So the concept of penetration testing for IoT devices was created to address the unique and significant security risk posed by rapid increasing of interconnected smart devices, presented new complex security risk than that traditional quality assurance testing couldn't adequately address. So concept penetration testing is based on performing activities that go beyond existing patterns present in the IT world. So today I want to show you from a business and technical perspective why this is important. So yeah, technology is developing at a very fast pace, and unfortunately, not always in the expected direction. So I mean the development related to hacking and attacking devices. And the concept of pen test is not new. Its creation dates back to the 1960s, 1970s, but the rapid development of the internet and especially the beginning of the era of global connected world led to need to develop pen test in order to make sure and verify that our IoT devices are properly prepared for the challenges that technology development brings. Okay, so moving on to the topic of the presentation, let's consider what questions we need to ask ourselves first before we start implementing pen test for our IoT devices. Penetration testing is a powerful technique, a process which may have significant impact on our systems. So, however, to maximize its value and efficiency, your business and technical teams need clear answers to these fundamental questions before launching the testing program. So, yeah, these questions help set the stage and define the scope of your efforts. So, at the beginning, you need to consider what our specific goals. So, this is the why question. So, why are we doing this? What outcomes do we expect? Then we need to ask what exactly are we testing? So this defines the scope. So are we testing hardware, firmware, or maybe we want to test surrounding ecosystem? Yeah, the question I mentioned, which I consider the most important and the ones that require the most work, as well as the others on the slide. So yeah, and all these questions will be answered during this webinar. So as we can see, all those questions concern both the business and technical domains, and without the joint cooperation of people from business and technical side, it can be very difficult to successfully implement penetration test in our projects. And yeah, before we go into the details, it makes sense to think and define what we are actually talking about in context of pen testing. So what exactly is embedded pen testing? So in simple terms, a penetration test for IoT device is a simulated cyber attack designed to uncover security weaknesses across the device's entire ecosystem, including its hardware, firmware, and all related components. It is about actively looking for ways to break security of a device. So the goal is to ensure that these devices are resilient against unauthorized access, data breaches, and other various cyber attacks. So yeah, the entire domain related to pen testing is connected by many processes, techniques. When use them in the right order, allow us to obtain the expected result. So, okay, so now we know what it is and what question to ask at the beginning. So let's look at how we can approach it. Yeah, in context of pen testing, I can define different approaches you can take, often categorized by the amount of information provided to the tester upfront. So, and here we can find three main approaches. The first one, the black box approach, means the tester has no additional information provided. So they approach the system like an external attacker with no internal knowledge, without any details about the communication buses, about the logic and how security controls work. The second, the gray box approach, involves providing basic information, perhaps about the logic, algorithms, or communication protocol use. So it means that we have some knowledge, some detailed knowledge about the system, and we don't need to start from the beginning. The last approach, the white box, provides all information about the device, including manuals, electronic schema, source code, and details about the logic and communications. So this allows for us very detailed analysis because we know everything about the IoT device, especially we have access to the source code, so it enables for us perform much more detailed analysis. Okay, and during the execution, it is recommended to implement three different approaches. So it means that to achieve best results, you need to implement flexible hybrid approach to optimize cost and time. And the main goal is to maximize vulnerability detection process. But unfortunately, there is no simple answer to how we should divide the time spent in the individual approaches. So everything will depend on the goals we want to achieve. And as we gain practical experience, we will begin to see advantages and disadvantages of each approach and how much time we should spend in each of the categories. And additionally, the chart on the slide shows how the approach can affect the number of detected vulnerabilities and threats. So each defined approach has its advantages and disadvantages, as I said, and we should not focus only on the white box approach. Okay, so now we know the definition and main approaches to performing a penetration test. So let's consider which elements of the embedded system should be subject to penetration tests. Yeah. In embedded system, we can list two main categories that will be important from the point of view of pen testing. So the first one, hardware, is a key element of the entire system. So when analyzing and selecting elements for testing in hardware, we must focus first on testing all wired and wireless communication buses because these buses will be a natural entry point to our system. Then our attention will move to the installed MCU, all integrated circuits that can perform specific logic, collect important information. And the next element will be all sensors and other elements that can affect the logic, like power supply and other important assets which are responsible for control some processes and behavior of the system. Okay, so the next group, testing, of which will have a significant impact on the level of security, will be a software that directly executes programmed logic, like dedicated secure environments like TE and other similar things. Then we need to focus on elements related to installation, update, manufacturing, maintenance, and put process. And at the end, we need to test all important software components like libraries dedicated to security and all modules responsible for implementation of functions which are important from the security perspective. Okay, so looking at the list of elements I presented, you are probably wondering, so why we need pen tests? So since the elements we are talking about are in most cases tested during the standard quality assurance process. And yes, and you're partially right, but if you compare traditional quality assurance testing to pen testing, it turns out that the differences are fundamental in some areas. So it is important to understand that traditional quality assurance testing confirms the system does what it should. So it verifies intended function and quality. And the question QA asks is, does it work as designed? So this is typically seen from the user builder perspective, focusing on the features and performance and looking for functional defects and performance issues. Okay, so in contrast, pen testing checks if the system can be forced to do what it shouldn't. So its goal is to find and exploit security flaws. And the question here is, can its security be broken? So this approach from the attacker or adversary perspective, focusing on weaknesses and potential attack paths and identifying security vulnerabilities and exploits path. So as you see, both are necessary, but they serve different purposes. So understanding these differences helps highlight why pen testing is not just another test, but a crucial security measure for the IoT devices. Okay, so now let's consider how to answer for the next question, which is why penetration tests are crucial for embedded systems. IoT embedded systems are becoming increasingly connected, particularly with the rise of popularity of Internet of Things devices, and this increased connectivity means that they are more exposed to potential threats. So not all systems can be easily updated or remotely repaired if any security related issues are detected. So embedded systems, embedded IoT systems may have weaknesses, and a weakness is an underlying defect that modifies behavior or functionality or allows unverified or incorrect access to data or other important assets. So when a weakness is exploitable, it's known as a vulnerability. And weaknesses in IoT devices can lead to significant consequences such as potential security incidents, equipment damage, or even operation shutdown. So to answer the question, penetration tests are therefore crucial in that they allow you to minimize the risk of weaknesses, increase the level of protection and reliability in context of security, and save the resources and time required to eliminate weaknesses that may occur later. Okay, so an extension to this question could be another that contains similar arguments and goals in the answer. And this question is why we need penetration test. So why exactly we need to put our IoT system through the rigor of penetration testing. So it might seem like an extra step, but in today's interconnected world, it's absolutely crucial. So let's break down some of the key reasons. First, and I think one of the most important is compliance with regulations. So in many domains, we can already find many regulations about security. So currently in the process of regulation regarding security, I think we are dealing with a revolution. So many countries are currently working on various regulations that will come into force soon, such as Cyber Resilience Act. But some countries have already implemented new regulations in order to raise the level of security, such as the US Cyber Trust Mark, UKIPSD. So most of the regulations currently being created are very restrictive and will impose many additional obligations on manufacturers and designers of embedded systems. So, okay, so going further next, and I think perhaps most obvious reason, we want to identify vulnerabilities before attackers do. So IoT systems and embedded systems are no longer isolated black boxes. They are increasingly connected, making them attractive targets. So penetration tests allow us to proactively uncover those hidden weaknesses, whether it is a flaw in the firmware or insecure communication protocol, or for example, unprotected debug port. So before a malicious actor exploits them and causes real damage. So yeah, and we need to remember that identified threats before attackers help us manage and reduce risk, especially when we release the product on the market. Okay, so nowadays, IoT system collect more and more data, and some of them we treat as a significant data. So this could be anything from the personal user information to critical operational parameters in an industrial controller, or any other important settings which may have direct impact on the logic. And in this case, penetration test helps ensure that this data is properly protected. And yeah, generally, in many projects, we implement many security controls, but how do we know they actually work as intended? So in real-world attack scenario, so that's where penetration test comes in. So it helps for us validate security controls. So this practical validation provides concrete evidence of your security posture and effectiveness, or highlights where improvements are needed. And additionally, by confirming the correct operation of security controls, we will minimize the risk of increasing cost associated with possible successful attack. Okay, so moving to the next topic, let's consider what challenges and problems we may encounter during the implementation of penetration test. So problem and challenges are a natural stage, a process that always appear when implementing new elements into our projects. So I prefer to treat all problems that appear as challenges and another step towards achieving goals and assumptions. So I do not treat them as obstacles, but as a subsequent steps that I must overcome to achieve my goals. So for better understanding, I divided the challenges into two categories. So one is the company perspective, and the second is a technical project perspective. So I think from a company perspective, cost, time, and scheduling are very important because the expertise and tools required, especially for complex systems, represent a significant investment. And another reason, tests take time. And because they are not just the testing itself, but also the planning, remediation, retesting, some fixing process probably will be required. And fitting this into into current development cycles and product release schedules can be a real challenge. Okay, so going further, you need to be aware that lack of expertise and resource allocation can be a big challenge because most of the systems demand a unique blend of hardware and software knowledge, which is often hard to find in a single individual. So in addition, not everyone finds this field interesting as it requires constant searching for new paths and going beyond the patterns. And during the test, we will find we'll find various weaknesses and threats, and then the problem will arise how and when to implement the required changes. So yeah, currently many projects are currently delayed, so not all detected threats can be easily fixed. Some will require changing requirements or even hardware. So yeah, in this case, interesting questions may appear is, should we stop release product on the market, or should we release even we are aware of existing issues? Yeah. Okay, so going to the second category, so the challenges from the technical project perspective, focusing more on technical aspects. So, and at the beginning of performing pen tests, we need to find a way where and how to start. So how to determine the paths and methods of attack. So what tools to use to effectively test possible approaches, what knowledge and qualification to gain about the device, protocols, algorithms to obtain the expected results. Another significant challenge is to build a test environment and the tools necessary for work. So, and I think in this case, a good example that comes to my mind is testing various wireless communications, because testing wireless buses can be a big challenge because we have to be aware that during the test, there may be other wireless networks within our range, which belong to other systems. So, and now, when testing our system, we cannot cause disruption or damage to wireless networks that are around us, because this can lead to damage to other system or blocking, for example, wireless communication, which at the given moment may be necessary to call for medical assistance. So it's very important. Okay, the last challenge I want to address today is the evaluation of the quality and results of tests. So especially if we fail to break the security of the system. So then we will start to wonder if we did everything correctly, or if there are any other ways, path, tools that are worth using, and we should back to the test procedure and test them. But I think a similar question also arises when we manage to break the system security, because we will not be sure whether there are no other ways to break into the system than those currently discovered by us. Okay, so challenges are easier to solve when we have defined approach and step what to do and when in context of penetration test. So when implementing new processes and activities for our projects, a question often arises about when and how to start and what steps to take first. So our main goal in this case of starting the implementation of penetration tests is in the acquired project is to move to the practical phase as soon as possible. So start performing tests, but before we start gaining experience through practical implementation, we need to focus on points 1 to 4. So yeah, without proper preparation consisting of building a knowledge base, practicing various tools, building a test environment and teams responsible for performing penetration tests, it can be very difficult to implement the practical part of the presented plan. Okay, in the context of building teams, it is very important to select the right people. Yeah, it should be avoided that pen tests are performed by members of the team responsible for the implementation of the project. And penetration tests are quite a specific activity, and not everyone is interested in this type of activity where the measurability of completed task does not always have a practical dimension. Okay, building, going to the next point. Building an appropriate test environment will be with the required hardware and software tools should be done incrementally. So as we gain experience, we should test new tools and implement them into our workshop. So, and additionally, it's a very important factor is building the environment in such a way that during the performance on penetration tests, we do not interfere with or affect or the system that are nearby. Yeah, I already mentioned on previous slide about this this challenge. Okay, and a properly constructed continuous improvement process allow us to create an development environment open to innovation and change in order to increase efficiency and productivity. Yeah. The last point I didn't mention is the process of identifying critical system resources. And IoT devices systems are usually very complex, so testing all system elements for security doesn't always make sense. So limited budget and resources drive us towards optimization. And saving in terms of time and cost can be achieved through a correct identification critical asset process. So this will allow us to define resources that are important from a security perspective by performing specific steps and only test them as an optimal plan. So in this case, a good solution is to choose a a process called threat modeling, so which is often used during the analysis, system design, with particular attention to important elements from the security level. But for pen testing purposes, we can implement a slightly simplified threat modeling process in which we avoid some of the points required by the standards, like, for example, define security levels or some additional requirements. And the fifth step we need to take is to create a system model where we will mark all important elements, data flows, communication buses, hardware components, and mechanics important from the security point of view. And next, having created a model, we can focus on identifying threats. And for this purpose, we can take one of the popular methods for identifying potential threats, and especially in this case, Stride works very well in the Stride methodology, works very well in IoT devices. And depending on the domain, we will have to use other required methods, because, for example, for automotive, there are requirements that we use Tara process, for railway, other process, and etc. So everything will depend on the domain. Okay, and the last point is to use the acquired knowledge to start thinking like a hacker who is trying to gain an authorized access to our system. So to do this, we identify potential attack paths, prepare a plan of action, and put ourselves in the role of a person who has a goal related to getting into our device in an unauthorized way. So penetration testing is very important, but without a proper implementation plan into our current software development process, meet all the goals can be difficult to achieve. So implementing all the elements relevant to security will be difficult to do quickly and effectively due to lack of resources and time. So, and in this approach, I propose divide implementation of penetration tests into two phases. In the first phase, we implement penetration tests into our current software development lifecycle, and we should start testing from the moment when the system is functional from the logical side, and some of the features relevant to security are implemented. It is not required to implement all the functions in accordance with the requirements. So through the analysis process, we must determine the moment when conducting tests can bring the expected results. And yeah, of course, the element tested during the product development process should be tested again when all the functions are available. But we must remember that the sooner we detect security-related vulnerabilities issues, the lower cost and time we need to spend to fix them, because we need to be aware that some elements necessary to implement regarding security may have an impact to functional requirements. Okay, and going to the second phase. The second phase is the process of transforming your current software development lifecycle towards secure software development lifecycle process, which will significantly increase the level of security and fully utilize the benefits resulting from conducting penetration tests. And when moving to the second phase, we need to be aware that correctly transforming into secure software development lifecycle, your projects will require creating a additional processes, as well implementing the required countermeasures necessary from the security perspective. And depending on the complexity, status of the project, this may take relatively a long time. But the good news that you don't need to start to define this process from the beginning. You can use your current process and just transfer them to the secure software development lifecycle process. Okay, so before we move on to the summary, I would like to show how penetration tests relate to other processes that are important from the security perspective. So achieving the required level of security that will allow us to secure our devices requires a number of activities to perform and functions to design and implement them. So as you can see on this slide, I present the entire scope of activities, processes, functions that will be required in embedded systems. So you need to be aware that without a secure software update, we will not able to effectively respond to detected threats and errors. Without encrypting data and communication buses, we will not be able to protect data, and it's important to the system and personal data. And without appropriate authorization and authentication mechanism, we're not able to protect against unauthorized access. So in addition to the additional to the security countermeasure that I mentioned on the slide, you can see other activities that are required in context of the secure software development lifecycle process and have a significant impact on the entire level of security. Okay, so as you probably know and guess, penetration tests correctly performed and implemented will allow us to check whether the functions that we have implemented in context of security work as they should. So even though penetration test does not add any features to the system that I mentioned, it does has a significant impact on the security of the entire system. Okay, so slowly heading towards summarizing all the presented knowledge, I would like to show the phases of penetration testing that I recommend, which we should perform periodically. So additionally, I have provided examples of time we should spend on each phase. These are average value from resulting from experience and completed projects from my personal experience. And I think as we gain knowledge and increase the level of security of our device, this time will be modified and probably reduced in many cases. So, but we should perform these phases sequentially, but is a need to repeat or modify the elements performed in the previous phase, we should go back and do it without having to wait for the next cycle. Okay, so at the end of our webinar, I would like to summarize in the form of 4 groups what we should remember when implementing penetration testing in our organization. So at the beginning, build expertise by defining rules, identify knowledge gaps and methodologies, and remember about security regulation, which are coming and will be obligatory very soon. So as I said, some of them already came into force. Second, implement appropriate approach, and without this, achieving success will be extremely difficult and time-consuming. So find the right approach to gaining knowledge and experience, and prepare a plan. And next, start the process of changing thinking. So, and appropriately selecting people necessary to build effective teams, I think will be a very important factor in this case. And third, do not run away from problems and challenges. So the sooner you face them, the sooner you will start achieving success and increase your productivity and efficiency. And the last but not least, continuous improvement. So this process can be, I think, the most difficult to manage and build, because without awareness of what and how we are doing wrong, we will not able to improve. So analyze results in details, build processes that encourage continuous learning, searching for new tools and methods, and analyze what you can improve, and try to automate everything you can in order to speed up and improve quality of your entire testing process. Okay, so I think it's today what I prepared for you. So currently, I think we can switch to the QA session. So give me a moment. I just open a window with questions and try to find those one. It's worth to answer. Okay. Okay, I think I found the questions. Okay, the first questions. Okay, I will read those questions aloud, because probably, yeah, you won't see those questions. So the first one, do you have dedicated teams in SII dealing with embedded pen testing? Do you conduct requirement internship courses in the field? Yes. Generally, we built inside the SII dedicated team, and currently we do some projects, and also we built some training procedures. We have some additional bench project on which we learn how to test some specific protocols, communication buses. So in this area, we develop. I think we started develop a few years ago, and still continue the entire process, and gather our entire knowledge to use in the further projects. Okay. The next question: what kind of tools are needed suitable for pen testing? Are there any open source tools that could bring expected effects, or rather to use commercial ones? Yeah, for regarding to tools, so in this area, I highly recommend use open source tools, because there are many communities and companies which work hard to develop very useful open source tools, which enable automate and by adding your own script programs to accelerate entire process and automate some tasks. But to effectively perform most of the pen testing, you will need additional hardware tools to perform some specific operation. And when you pay for those hardware tools, very often you already get dedicated software, but from the other side, commercial tools are also very useful, but some of them are quite expensive, but generally depend what you want testing. But because in some cases, commercial tools will be better and allows faster achieve goals. And I think good example comes to my mind is testing wireless buses and wireless communication. Because yeah, okay, we have many open source tools, but especially when you test Wi-Fi, it's better use some commercial tools. And as you see here, here is no simple answer. So it generally it will depend of purposes, what budget you have, and what are you going to test. Because as I said, for some of the components, open source tools are totally enough. Okay, so let's go to the next question. So, what are the most common attacks, vulnerabilities in the embedded world? Generally, it depends, but in many cases, it depends on the domain, because you need to be aware that when you specialize or you want or you have a device from one domain, you need to discover what kind of attacks are popular on this domain. And some of the organizations publish every year some threat landscape reports, and inside those reports you can find which attacks are more popular on which domain. So it's not working that way that, for example, for automotive, some tampering or spoofing attacks are popular, but from the other side, for medical devices, attacks which rely to store data are more popular. Okay. Next question. Should we perform a pen test for devices not connected to the internet or device that sporadically send data? So in this case, these questions, most of the standards regulations say that you need to protect user data and other assets which belong to the user. And they also say that you need to test all devices which are connected to the internet without distinction if they are used internet frequently or not. But most of the regulations, they are not require protect your technology, know-how, your algorithms. So of course, yeah, we need protect user and data and assets belong to user, but we need to think about our technology created by us, because if attacker able to break our device and get access to the firmware and detail some parameters, then we'll able prepare similar device and start offer a clone of your device on the market at, for example, lower price. So, and it may cause that we lose market or our client. So in my opinion, even device is not connected to the internet, I recommend perform penetration test and check if our device and our technology is protected against copy. Okay, how next question. How will CRI, Cyber Resilience Act, impact on the market in the EU? Will there a big impact of current products at that market? Yeah, to simply answer for this question, totally yes, because CRI will require totally change the processes and way how we design and implement our products, because CRA will have direct impact on each aspect during the implementation phase and will require implement many additional activities like penetration testing, like secure software development lifecycle. So I think CRA totally will change how we design and how our approach is in context of developing IoT devices. Okay, so I think there is some more questions. Yeah, maybe I will answer for the last one because I think our time is almost up. But let's answer for the last one. Should penetration test include cloud components? Yes, generally we need to test cloud components, but maybe we do not need test cloud as itself, but we need to test communication between our components and the cloud, because during the communication process, we will exchange handshake, we'll exchange user password, and we will exchange important data, and we need to be sure that those connections are established in a secure way, and we can exchange data with the cloud without any problems, and without a way that someone will able to get access to our data. Okay, so I think I answered for the most of the questions. I think our time is up, so maybe if you will want to continue this topic and you will have some more questions, you just contact with us and then we will try to answer for them.
Okay, so that brings us to the end of today's sessions. A huge thanks to all of you who joined today's sessions, today's webinar. A special thanks to Marek, our presenter, and the entire team behind the scenes. We hope that you're walking away with some practical insight and fresh ideas on how to strengthen the security of your IoT devices through pen testing, basically. As promised before, we will be sharing and sending out the recording and slides most probably on Monday. And if you would like to dive deeper or explore how our team can support your embedded systems, your devices, how to perform testing, feel free to reach out to us. We're happy to continue the conversation offline. Until then, stay secure, stay innovative, and thank you again for being with us today. Have a great day.